This video is an introduction to polynomials and the properties of polynomial functions. So any function which can be represented as the following type of series, where f of x is a sum from 0 up to some integer n max of an times x to the n, is a polynomial. So these numbers n are going to be some natural number, so some number starting at 0 going up to infinity in principle, but they are positive integers, and 0. And these numbers an are going to be any real number. So anything that doesn't have any imaginary component, doesn't have to be an integer, doesn't have to be a fraction, but anything that is a real number. And then this value n max is called the degree of the polynomial. And the degree of the polynomial tells us some useful information about it for doing things like adding and multiplying it with other polynomials. Okay, so let's look at some polynomial functions and what their order is. So things that are polynomials would be f of x equals 4, f of x equals 2x, f of x equals x cubed, f of x equals 2x squared minus 4, or f of x equals, say, x to the fourth minus x cubed plus x, or f of x equals 0. Okay, so what are the order of these various functions? So 4, the order of that would be 0, because the highest order x that it has is x to the 0. X to the 0 is 1, so this is 4x to the 0. 2x, that's x to the first, is its largest power, so that's 1. X cubed, order 3. 3 is its highest power. 2x squared minus 4 is order 2. This is an order 0 term, order 2 term. Then we have terms of order 4, 3, and 1, so that's order 4. And lastly, the special case is f of x equals 0, which in order to make a lot of these future properties work out, we have to define the order of that as minus infinity. So that's really the only confusing case there, is that f of x equals 0 is defined as minus infinity, but that'll become clear in a second why that has to be the case. Okay, so let's define another function now called g of x. Let's say g of x equals a sum from n equals 0 to, let's say, g max of bn times x to the n. So once again, we have a real number, bn, we have an integer, a positive integer n, and we have a sum of this term, which represents our second polynomial g. All right, so first we have that the degree of g of x is going to equal g max, as I've defined it up there on the term. The highest value for which bn does not equal 0. So we are going to do some things in terms of adding and multiplying these. So what is the degree of f of x plus g of x? So if we add f of x and g of x, what is the degree of that function? So that is going to be less than or equal to the maximum of the degree of f and the degree of g. So whichever one of these has the largest degree, that's the candidate for what the largest degree could be of their sum. But for example, if their largest values, like if this is x cubed plus x and this is minus x cubed, then their coefficients a3 and b3 are the negative of each other. So a3 plus b3 would cancel. We would just be left with a first order polynomial if you had x cubed plus x minus x cubed. So it produces an upper bound for what it can be, but the degree can be anything lower than that as well, depending on what the coefficients an and bn are. All right, we also have the degree. What about when we multiply polynomials? So f of x times g of x. Well, that is going to be the degree of f of x plus the degree of g of x. So if I take a third order polynomial and I multiply it times a first order polynomial, the result is going to be a fourth order polynomial. Degree 3 plus degree 1 gives me degree 4. So 2x times x cubed is 2x to the fourth, which would be a fourth order polynomial. Okay, so what are the explicit forms for what these series actually look like? So we would have, in order to sum two polynomials, f of x plus g of x equals sum n equals 0 to whatever the degree of this function ends up being. So that is going to be an plus bn times x to the n. So we're just summing the coefficients here. So if we want x cubed plus 2x, that's just x cubed plus 2x. If we want x to the fourth minus x cubed plus x cubed, that's going to be, these terms cancel, that's going to be x to the fourth plus x. So that's how it's going to work for summing. And then multiplying, again, as we're taught in Algebra 1, multiplication, let me write that out. It's going to be a sum from n equals 0 to the degree of f plus the degree of g, writing that shorthand because I don't have a lot of room up there. Sum from m equals 0 to n on the interior, a to the n, am bn minus m times x to the n. Okay, so this internal sum is basically just saying find all the terms that are of degree n and multiply, find all the terms where their combined orders add up to degree n and multiply those coefficients and sum all of those ones up. So for example, if I want all the second order coefficients in the product of, let's say, where am I going to get some here? Well, I don't think I have any that are going to work that way. Okay, let's say we had, all right, well, we'll find an example below to see how that works. All right, so an example of addition. So let's say x squared plus 4 plus x cubed plus 3x squared minus 2x minus 1. What does this equal? So so we're just adding up the coefficients at each order. So x cubed, there's only one x cubed term, so that stays. X squared, there's a 3x squared here and an x squared there, so we get plus 4x squared. There's one first order term, so minus 2x. And then we have plus 4 and minus 1, so that leaves us with plus 3. So very straightforward, exactly what we learned in Algebra 1. And then if we have terms like 2x plus 1 times x squared minus x, then we do our old friend, the FOIL method, where we're multiplying all terms times each other. So as I said, 2x times x cubed is 2x to the fourth, but these are all what are called monomials. These are one term. So this is a monomial, that's a monomial, that's a monomial. There's one term in each of them. This is a binomial. There are two terms. Each of these are binomials. This is a binomial. And this is a trinomial, and then it goes on from there. So when we're multiplying binomials, we get 4 terms. If we multiplied 2 trinomials, we would get 9 terms. We're multiplying all the terms times each other. And then we're going to get, for the result, we have 2x cubed from the first part. We have minus x. Then we have minus 2x squared. And we have plus x squared, which is going to equal 2x cubed is the only third order term. Then we have x squared minus 2x squared gives us a minus x squared. And then only have x, we have a minus x. Okay, so that's the basics of polynomial addition and multiplication. the degree of polynomials, and that polynomials are any function which can be written as this series, which is a series in positive powers of x to the n.